By integrating these advanced robotic systems, we've revolutionized the assembly process, ensuring every weld meets the highest standards.
In Widebody, the manufacturing process is highly complex, involving thousands of steps. Let me show you how these massive...
The assembly process here is a symphony of precision. Every rivet, every weld you see contributes.
Built to withstand incredible loads, this gear is essential. And here, we see the future of flight, the intricate design of robotics. This is the heart of the Boeing 777, a marvel of modern engineering. As you can see, the scale of this facility represents the cutting edge of aerospace engineering. Let's take a closer look at how these giants of the sky begin to take shape.
This section here needs realignment before the next phase.
Understood. I'll update the sequence parameters on the tablet.
The structural integrity looks good on section 4.
Acknowledged. Uploading the revised schematic now.
The laser alignment here seems off by 2 millimeters.
Let me check the schematic reference on the tablet.
Check the specifications for the riveting pattern right here.
Pulling up the schematic now. It calls for the high-strength aluminum alloy bolts.
Run the scan sequence now.
Starting the sequence, data coming through on the tablet.
The robot is detecting a microfracture on this blade.
Confirm the coordinates on the tablet.
We're finalizing the connections for the high-pressure fuel system. Every wire and pipe has to be perfectly aligned for the engine to perform optimally.
After final inspection and approval, engineers utilize augmented reality overlays to verify every detail of the assembly process. And translation. Audio gives the deep, resonant hum of powerful machinery.
Here at the facility, human expertise and robotic precision converge to build the next generation of aircraft.
We need to verify the alignment here before they bring the next section down. The tolerances are tight.
Diagnostics are green, but let's double check the rivets near the spar.
Ensure the torque is precise on this one. Got it. Moving to the next sequence now.
From the initial holographic design to the synchronized movements on the assembly line, technology is redefining aerospace manufacturing.
Check the routing for the yellow bundle.
It matches the diagram. We are clear for connection.
See this connection here? It's supposed to bypass the main relay.
Got it. I'll reroute the blue wire now.
I'm opening the main valve now. Check the pressure gauge. It's holding steady right at the limit. We have stabilization. We need another quarter turn on this one. Hold it steady.
Clear.
The assembly process relies heavily on these advanced robotic systems, capable of precision cutting and welding that human hands cannot replicate.
Look at the trailing edge of that blade. We're seeing some delamination here.
Yes, the scan confirms the subsurface damage. We need to escalate this to QC.
All right, slowly lowering. Watch your clearance on the pylon.
Copy that. Steady, steady. A little to the left.
Clear on the right side.
Torque setting is 7 to 5 Newton meters.
Reading confirmed. Apply pressure slowly.
Check the alignment on port 3.
The robotic arm sequence is running smoothly now.
Good. The pressure readings are stabilizing.
Instruments. Utilizing advanced robotics and meticulous hand finishing, we guarantee the structural integrity and aerodynamic perfection of.
Okay, bring it down slightly on the left.
Right there?
Yes, the laser is aligned. Lock it in.
Initiate the flight control check. Full forward deflection.
Roger that. And checking the spoilers now.
The assembly process requires absolute precision. The robotic arms handle the heavy lifting, while engineers meticulously inspect the fan blades.
Hold it there. Are the seals aligned?
Yes, the pressure readings are stable. We are good to proceed.
Check the alignment on this panel here.
The sensor readings on the tablet confirm the specifications.
We should run a secondary diagnostic just to be sure. The next sequence is here, just above the strut.
Understood. Moving into position now.
Check the routing on the blue bundle, section 4.
Verified. Ready for tie down.
I've secured this line. Can you verify the connection point?
Yes, the alignment looks precise.
The thermal mapping on section 4 indicates a slight anomaly. We should verify the riveting density there.
I agree. Let's cross-reference with the latest scan data.
Clear on the right, keep it coming down easy.
Holding steady here, looks good.
Check the routing on the blue bundle here.
According to the schematic, it should be secured at station 42.
Okay, the thermal scan is complete on this segment.
Hand me the reader. The blueprint suggests a potential anomaly right here.
Pressure's bled off. Gauges look good. We are clear?
Looks like we got a pass on this section. Great, I've logged it.
This bolt needs calibration according to the schematic.
Auxiliary systems online. Moving to avionics check.
Keep it moving right there. Watch the clearance.
Got it. Looks clear up ahead.
See the stress points on the diagram? We need to ensure the robotic arm applies even pressure right here.
Understood. Ramping up the hydraulics slightly.
Scan complete on section 3. Data synced.
All right, the readings look nominal.
This connection point seems slightly off.
Let me cross-reference the schematic.
Careful with the torque on that connection.
Got it. Calibrating now.
We need to check the hydraulic line pressure here.
Okay, I'm getting a reading now. This actuator looks loose. Can you tighten it up?
Yeah, I got it. How does that feel?
Perfect, looks good to go.
Okay, easy now. Align with the shaft.
Alignment confirmed, shaft engaged.
Perfect. Secure it in place.
The deviation on panel 4 is outside the tolerance.
Okay, I'll rescan that section now.
This panel here shows a slight discrepancy in the alignment data. My readings confer that. It's marginal, but we...
Scan complete on section 4.
Readings look good. Log it.
The reading here is 0.03393.
The spec sheet says it should be closer to 0.029. We should re-verify this section.
We need to check the hydraulic pressure on the main strut, and the tablet is showing a slight deviation from the baseline.
All right, check the connection point right there.
Confirmed. Resuming torque sequence.
Hatch sequence initiated. All primary indicators are reading green.
Confirmed. Pressure holding steady.
Here at the facility, our robotic arms handle the precision assembly of the wings, ensuring every component is perfectly placed before moving on to the engine installation.
Center, Speedbird 770 Heavy, maintaining flight level 350.
How's that pressure looking? It's good, cutting right through the grime.
Clipper 7 Heavy, pushback approved, runway 27 right.